question, target sum. Actually, the question is saying that you have to use all element of this array, and you have to take either positive or negative of it, and you have to print the total number of way we can create uh, the target sum, okay, using these all elements. Yeah. So is it looks like similar to 01 knapsack problem? Actually, in 01 knapsack problem, we were allowed to uh, we have some target, okay, that was the bag, the capacity of bag, and the condition was that either you have to pick this item or you don't have to pick this item. There were two conditions, okay. Here there is two conditions, that is either you have to take positive of it or either you have to take negative of it. And okay, so are you relating it with knapsack problem, 01 knapsack problem? Okay, now there is a question that is it bounded knapsack problem or unbounded? So this is bounded one. Like we have to use each element only once. You cannot use same element more than once. Okay, so is it clear? It is similar to knapsack problem. Okay, so let's do it. How we can uh, approach. So first we have to find the state. So at which where like how we can decide the state. So a state will depend on two things. First, that where we are, what is the current target. Okay, let's say first thing is that where we are. Okay, let's say we are at this index. So it's mean that we have used these things earlier and we have to use this. Okay, and second condition will be the target. Second thing will be the target, like what is the current target. Let's say if we use this as positive, then now the current target will be 2. If we use this as negative, then the now current target will be 4. So our state will depend on two variable, the index and the current sum, okay, current target you can say. Now so let's create a helper function and it will return the answer helper. So the index where we are and into the current target okay. Let's define these things and target here. So how many condition, let's say if we are here using this using this, like we have to add na, let's say considering positive of it have five ways and considering negative of it have 5 ways. So how many total ways? So it will 5 plus 5, it will be 10. So we will consider uh, the sum of it. Okay, so helper index plus 1 and current target minus nums of what index. Why we are doing this? Because we are considering that we added these things in our target, plus helper index plus 1 and current target plus nums of index. Okay, we will return this and let's write here vector and let's pass this as well. Hmm. Now consider, think about the base condition. we will have uh, when we will say that we have reached the boundary line. Let's say if we reach index equals to the size of this array, it's mean that we have visited all elements, and then current target equals to 0. It's mean that we don't have to like we reached that target. Okay, we don't have to explore anything more. So here in this case we will return 1. So this will be the one case. Else if index is greater than or equals to nums of size, then return 0. Okay, yeah. So let's do this helper. Okay, first initialize n will be equals to the nums dot size, and int target will be equals to target here, not int. We are just initialize it. We have just declared it in our we declare it in private variable. Okay, and let's return the helper. Let's call this helper function nums, and then index will be 0 and target. Yeah, let's run it. Let's test for some other 0 comma 0 comma 0, and let's write it here 0. That's good. Let's submit it. Accepted. Now we are we can think it like this. At some place, let's say we consider these things here as a negative. Let's say we take it positive and take it negative in first condition, and we want to find some target in this, and target will be 3. Now let's say just swap it. Let's think that we consider this negative and this is positive, and another another way this is positive and this is negative. So we are computing same things multiple time. So why we are doing that? We can store these things. So let's decide which type of cache we have to generate. Type of cache. Okay, why is that so? Because the target might, let's say if we are considering the array, okay, and the size will be index the size of nums and the target, then there might be condition, some situation that target will be negative. It is given in constraint, so we cannot think about the vector of vector 2D vector. Okay, so we can think about map of pair and int. So pair will be will contain index and current target, and uh, the second key of map will be the answer. Okay, so let's define it. Let's define it as a map and pair of int, comma int, and this will be cache here. Auto find equals to cache dot find index and current target. If find not equals to cache dot end, then return find dot find second. Okay, and here we have to store it. Current target. Okay, and let's submit it. That's good. Cool. Thank you. So just think about time complexity. In first approach, in a recursive approach, the time complexity were to the power what to the power n. Sorry, n to yeah to the power n. Okay, and in second approach, after using this cache tabulation method, we are computing only n squared. Time complexity will be n squared. The index, the n will be like the size of nums, and the second will be target. So size of nums into target will be the time complexity, and the space complexity will be same in second case. Okay, that's all from my side. Thank you.